Nice to meet you to this new episode of Weekbit. Yeah, on my kitchen table the NAD compact disc player 502. And what's happened? It would be analyzed from another technician, and he said I should all change all this. Yeah, we have a watch in the plan. What is this all? Everything. And I show it at first what we would like to change, and then I change it on this machine. It's also open now, and sometimes I get a machine where I should only change the parts and not analyze the thing, what's happened with it.
Now we are on the NAD 502 CD player, and what we would like to change is from the sleeve motor, these two transistors, what making the sleeve motor to the outside of the disc and to the inside of the disc. And secondary, what we would like to change is this IC. This is also an IC, the TA7256. This should be also changed. It's an amplifier for the spindle motor, and also this from here, I think so. This pickup, laser pickup, coil pickup. That should we change? Yes. Then we should change the transistors Q504. This is a 2SD2012. This is the NPN, I think so. And here the Q503. This is the 2SB1375 transistor for the power supply. That we should change these bars. Yeah, and this we would like to gonna do now.
Oh, we have the CD player here. I open this. I don't analyze what is for failure. We changed it only blind. In case of that, that is a standard thing. He told me. Oh, here are the screws. And I also got the tester. We have the tester here, and we test the parts before we build it in. I have sometimes that we don't I analyze it, and then we have a big issue. Yeah, what is this? Q503. Q503. Is it the Q503 that we should change? No. No way. Maybe we change also the capacitors, huh? This will be also a cool thing. What's happened now here? We put it here. And 501, 502, 504, 503 have a regular cooling thing on it, and this is the other, this is the 504 transistor. Okay. First what we're gonna do, we disconnect the drive. And then disconnecting the drive. And we put that out of the case, of the body, and we need to you need this, put the screws inside. Do that all the time with that you don't lose some screws. All screws must be back in the same position where you build it out. And important, I cannot say it 1,000 times, and often disconnect the mains. It's also for your safety and for the safety for the machine. We like to build that out. Also we disconnecting this connector here from the display and front panel. Yeah. And we must also disassemble this. Oops. And then we would like to, it's not possible to bring that out here, no problem. We must remove, we must give the screws back and we must remove the front. I thought I can. Oh my gosh. I thought I can remove the back side and bring it out. Sometimes as I remember that it's working like this, but now we must open the front. Be careful on the side. These are the plastic screws that fix this and hold this in place. Not correct to fix is that this fall not off, and so just remove this, and also have on the other side, you see that on the left side, in the center and on the right side. We must remove the screws that we can pull off the front part. In that case, that we can move out with the board. And also here on this side, it's not the left side from the top view, but here is the right side, and so it comes out. Yeah, and then we can see here also it's the quality pass. You look here, it's from 95, 13 week 95. Oh, sorry. You can see that. Is that in focus? No. It's 1995, and the 13th week, I think so, I can read here, 13th week, the quality control. How we can move that out now? It's near impossible. In case of this doesn't fit. We must connect I think so, we must connect this back, this motor, switch it on. Is that this motor? No. Could be, or not. Or is it here? We must move the tray out, and doesn't drive. Oh, this is also not the motor. This is the motor. Oh my gosh. This is the... What are we gonna do? We must connect all this back, and then doesn't move out. Interesting, why? Switch it off. Then the tray motor will not open the tray. I'm testing it again. Oh, it's here. One moment. I must put that back, the connection. Interest. Here is a pin out. This is interesting. Here's the pin out. Look at this. Maybe it's going out during your hair. Now it's in. And now the player is working, huh? That will be cool, huh? If that happens. No, only this pin is going out. Very funny. Yes. Something is working, and now we maybe this was the failure. No, cannot be. We change it too. And no, nothing happened. Spin motor doesn't open. Okay, no problem. We make the short test, but now we must release the thing here to up. You move it only up a little bit and then close the door, and so you can deinstall the front to change all these parts. This will be needed. Not so easy, but it's okay. Look, here's the part, the front, and here you have the buttons and the cable too here, and also you have the buttons here. It's very simple. And now don't forget to disconnect the connector, the mains connector, and now we would like to build that out. It's easy to understand. First, what we're gonna do is there is a plastic thing. Look, this here, and be careful. Here is a resistor, and if you can see this, we must remove that with a small pliers. It's here now, and we remove that plastic pin. I don't understand why they're making a plastic pin here. Look, it's going out now and fall off. And we have here also a screw. Should we remove it or not? It's not necessary. We can also solder it here. You can see it. It's not so important. The first thing what we remove is the transistor here. Or should we remove it here? We disassemble this too. It's not good. We have this here. It's the grounding for the board, and we put it out. Move it a little bit around. We put it out, and it's not possible to move that out. You have a screw here too. Oh, okay. We must remove this screw too. Yeah, you see, long time I don't work with this machine. It's really long time. So now we have the board here, and we can. It's not possible to do it here. Okay, so. The first what we're gonna remove is this Q504. Q504 is 504. It's the D2012. D2012. This is this transistor D2012. We have it here. Search it, D2012. It's not here. It should be we don't should this remove. It's a LM340. LM340. We remove this transistor, this Q503. Q503. This is this transistor. We remove that. This is the green one. Green one transistor. It's the USB 1373. Look. You can see it. And the first what we're gonna do is we test it with this machine here. It's a little bit, it's a little transistor tester. We put it here in, and 1, 2, 3, and test it. What's happened? It's a diode. Very funny. Things have no contact also. It's a diode. Super. Maybe it's a FET transistor. No, it's a diode. No, cannot be. It's a diode. It's defect. Give me a defect transistor. Huh? It's a diode. B1372SB. 2SB. 2SB1375. It's a normal transistor, but this is only we are used and we have a problem. The part is defect. Oh, the transistor is defect. I tested also on the measurement. And yeah, okay. We let that be, we don't change it. What is the 340? This we can change. This I see here. This we can change. Should we change it first, or should we change the transistors here? I have here 4 transistors, and yeah. First I would like to change the Q604, and it's here. I show this now. The Q604 is here. 604 is here, and we change it first. That we solder it first a little bit, and then it's falling off. Okay, but the hose we must okay. You hear it clack. It's falling off in a second. The idea is not so bad, and then we have interesting. And how was it built in? No, no reason. I don't know. I must watch on it with my lamp, and so I can see it better. What's happened? This is the 1225. 1225. Okay, the 1225. 1225. We take one 1225. Oh, it's the wrong one. Here is the 1225. Okay, and we put it in. In the correct direction. We build it in. I must hold it a little bit and solder it. Now I need 3 hands to do this. A third hand will be nice. Look, it's going around, huh? Okay, one pin is soldered, and this and that. This is a little bit too much, but that's okay. And now we must remove the second 12. This is here. All facing like this direction. I mean, here is the, if you're viewing like here is the print on it. Next one we solder on is this. Falling off or not? And maybe you can see this. I desolder it. Oh, it's not falling off. We can remove it with these pins here. Zack, it's falling off now. It's the old one transistor. Oh, it's hot. Power. Don't hold your fingers too long to the soldering iron. Here we have the new 12 something, and we make a test. Is it good or not? It's good. Okay. We put it in, hold it, and then we solder it. Hold it, hand over. It's falling off. We must put it in again, and then maybe we can hold it. Also, we can bend the feet a little bit, the pins. Does not fall off because we can hold them here, over here. No good. Ha 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 ha. Hold the other. Ha 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 ha. And we must solder it here and then here. So, and then we do the other, the Q607. Pull off. And then, it's quite heavy today. We test it again, and it's okay. Looks okay. We have the same thing. This is the 909. Put them in. Okay. Ah, hot. Cannot be. What's happened today? My mental health is now over. First it holds on the pin and then doesn't hold. Just look. Doesn't hold. This is interesting. Why? The thing is not holding. This is interesting, huh? Why not? Cannot hold on the pin. 2 times fall off. I mean, hey, come on. What did you think? The pins doesn't hold. You cannot solder it. It's like impossible. Okay. If they think like I'm give up, I bend the pins. Why not? I bend the pins, and if it's not soldering now, we must doing some other processes. How can I solder this if it doesn't fit? Oh, now it's working. You see it? Okay. We put them out. Ah, it smells like burning PCB, and oh, I cut it, but not too much. And if you got this NAD, you must change this. Oh my gosh. It's, yeah. It could be work, but it should. Also, taking this transistor, putting in the tester, test it, and okay, that's good. Houston, we have the transistor here. We change it to this transistor. And I also bend it. Cannot fall off during my soldering, and I don't burn my fingers. Yeah. This what I also must mention is this. I'm doing this with normal transistors, not these square transistors. Yeah. how it can be that this not be solders. That means they are over, you know what it's, they are too long in stock. Yeah, this is my mind. They are too long in stock, and so their corrosion is on the pin. Next time we doing the anti-corrosion. You see that? Doesn't solder. Yeah, you can say take a flux, yeah, but this is not. So now it's better. I think it's better. Yeah, the middle pin doesn't want to be soldered. This is interesting. Huh? They are maybe transported by the ship, and so the corrosion from the salt from the sea. But it's good. Look, it's good. This is the servo controller, I think, and here we have the mesh board. So here is the signaling, here is the mesh board sensor with my finger. Now we are making the photos. We are soldering these joints and these joints. It looks like corroded. Was one guy who said we should clean the print. Yes, we can do that. It's also a good idea, cleaning the lens and cleaning the print. And here we change this IC2. It's also for the interface. But first we solder it, then we can build it out. Yeah, I build out this IC in case of that the camera doesn't work in overheating mode. Sounds like this, the transistors, and now we would like to build in this. It's the same. Part number 1 is here. You can see that it's here. Yeah. Here's the number 1. Further, I clean this up in case of that we don't have so much. So we only with this brush I clean it up first a little bit. For this case here I solder this and these two I solder. You should do in case of this is over the running time. I think so the electrons are moving the material from this IC away, and now we having this here to it's good. It's not so oxidized. We should change the supply too. Super. This is wrong. This is wrong. Sir, it's wrong. I must desolder it, these 2 pins. No, it's good. And good. Looks good. Now I build it in again. You cannot change not all the things, but we change something. And we build it in. Attention on the back side, you must bring all these connectors in position, and we move that back. So super. I also want to bring that back to, we must mount it here. And then we must connect all the things here. That I'm gonna do now. First, what that metal connection here, the grounding. It's fall off, fall off, fall off, and again fall off. I mean, come on. That cannot be. It's fall off all the time. Do we have here so big magnetic fields that all the 5 seconds it's fall off? Cannot believe that. Yes, I can insert the screw, and yeah, that was it. Now the second one, 1,000 times fall off. Or maybe the okay, super. We must connect it. Where it should be. White to red and white to white. So I mean, this is not funny, but okay. They don't have so much connectors here. And now we must position the front and hope so that the machine is working. We only can hope. I don't make an analyze on this machine. Analyze we give out of the house. And if it is so, then it is so. Interest. Why cannot click in? Sometimes it works, sometimes not. Go in, go in, go in. I feel sad if I cannot put this back. It's interesting. Why? Why? 1,000 times why. And here we must put that back, but be careful that all the pins are in. Now we hope so we can start it. Maybe the transistor was defect and this IC. Now we can start it. And tray is open, tray is closed, and nothing spins up. Why? And if no CD is in, laser light is coming. Moves not up and moves not down. No laser light. There is no laser light. And how should that work if no laser is there? Interest. No laser light, that means that these are 113 also. We must search in the plan. Oh, what I found out is that this B and the A connector was wrong connected, and so it runs. Play. Oh. Why that was interchanged? Oh, I don't know. You hear it? Yes, and of course, we're doing the recapping. I have here the capacitors. We're doing these two, and these two. And so we start here for 7 microfarads and 7 microfarads. Oh. I build that out. Oops. Sounds funny. These two outs. Kicked it away and we build in new ones. We don't measure it. Forgot it. It cost a 10 cent or so, one capacitor. And after these years running time, it could be okay, but change it. If we have it open, the machine, then we change it. If we have it closed, then don't change it. But I'm taking bigger ones with a higher voltage. You can see it's a 470 microfarads with 50 volts, and this is a 470 with 16 volts. We change it to this because I only have the high voltage. We bought only these cheap capacitors in case of what? In case of that we would like to have a watch on it how much watt it have. And you see, we don't have a space problem. We do this, and now we solder it in. High voltages are possible, low voltages are not possible. Simple to understand. That makes sense. We have this so, putting this so, and that so. Perfect. We only must cutting the leads. You must cut the leads in case of that this doesn't contact the floor. The next what we're gonna do is we are, oh, this is a little bit bent, huh? So it's better, looks better. Changing these fat ones. Attention, don't make a short, it can be loud and so it's not funny. If you have the lightning, oh, this was not good. That was not good. You see that? Making a disconnection from here to here. It interrupts. This is not funny. You see the pin is broken and we must making some things on it. We must do that like this. You see? Just shave that vac-rail away that we can. You see the pin is stand up. Look, pin is standing up. This is not good. That comes if it is glued. It's glued, yeah. The capacitors are glued, and so this can be that it jumps back the glue. Look, knacks is also making these knacks. Not good. Ah. You hear that? Because they are glued on the, you see it? Here is the glue on the side. And we must also do this here to hole is open, but it's okay. Looks good. And we also, I don't understand why they're making the tracks now so small, and they center the grounding. They center the grounding, but it is not that what we want. This star should be central. Is this the central of the power supply, or is this the central of the power supply? We don't know. Oh. It depends on the resistance. Okay, there we have the 2.2. We must solder this here. Look, and that there also too. For to fix the pin. Then we give the 2200 farad. Oh, we beat that out. This was better, huh? It's better. It's better, baby. Yeah, it's cool. We are bent this lead. And make a big track here to this place. Okay, super. Now we are cutting the leads again, and we do that on the other position too. Here we got this. And why they are gluing this? This is also an interesting question. Look here, we have now the issue. Come to the hole. I hold it here up. We are solder it here and here, you see? And then we solder on the other side. During transportation, the capacitor have a wide end, also after, but if it's shaking, these tracks can be cut off during the transportation, and so you need to glue the capacitors. This is the background, why they glue it. Yes, this was the NAD C502, and with the defect lead motor transistors and this IC what is going for the focus regulation, we change it. Yeah, and it's working, but what I found out is the sound quality is not so good, and so is that the other issue, or is the sound transistors from the muting are not good? And there are a lot of questions what I cannot answer in the first repair. But it works. But it has not so excellent sound. This is interesting. It's good, but it's not excellent. Yeah, like NAD have excellent sound. Yeah, but this is not so. Maybe we must change the mesh controller for the better sound quality. But I don't know what's happened with this. I must interest more on measurement technique and found out what happened exactly. I changed the capacitors to power supply is good, and now it's interest. Between good and excellent is a step. Yeah, and I cannot give it back if it's not excellent. If you like my channel and also repairing, take a question in the comment line. We have now starts a community, and I say thank you for the 999 subscriber. I don't know, I have 1,000. It gives a party, man. But we're repairing CD players, or I repair CD players, and we are hi-fi friends. And if you like my channel, please subscribe. And I say thank you for watching.